All right, this is packet to review. So on these first four were absolute value equations, and you probably haven't done them since Algebra 1 or even before. So be sure to listen very carefully on these. So on this first one, to solve an absolute value, you get two equations. So on your paper, go ahead and draw a line right down the middle of your box. You're going to have an equation of 2x plus 7 equals 5, and 2x plus 7 equals negative 5. So if you notice what I've done here, I've changed the sign on what my equation is set equal to. Okay? Next, we just solve for x. So on both equations, I am subtracting 7. Alright, now after I subtract, I just divide by 2, both equations on both sides. So I'm left with x equals negative 1 and x equals negative 6. Okay, so that one is pretty easy. For the second one, you'll notice that we have more than just an absolute value on the right side of our equation. So in order to get rid of that, because we just want the absolute value there, we have got to add 1 to both sides. Once we add 1 to both sides, we have 17 equals the absolute value of 4k minus 3. Okay, now just like before, we get two equations. So we're going to have a 17 equals 4k minus 3, and a negative 17 equals 4k minus 3. For both equations, we are adding 3. We're left with 20 equals 4k on one equation, and negative 14 equals 4k on the other equation. Now the only thing left to do is divide by 4 on both sides on both equations. The one on the right leaves us with k equals 5. And on the second one, it leaves us, we just simplify that fraction to negative 7 over 2 equals k. So these two absolute values have two solutions each. Now, if we look at number 3, we have to do two things to get our absolute value by itself. So first, we have to add the 17, and we're left with negative 2 times the absolute value of w minus 6 equals 20. Then we must divide by negative 2. And we are left with the absolute value of w minus 6 equals negative 10. So just like before, using this absolute value equation, we get two equations, two new ones. So w minus 6 equals negative 10. And w minus 6 equals plus 10. So when you add 6 to both sides for both equations, for one of them you get w equals 16, and the other you get w equals negative 4. Now, think back to a couple of weeks ago when we did quadratics and stuff. What did we have to do with our solutions? We had to plug them back in. Okay, so on this example, or on these examples, you want to plug your numbers back in to see if they work. Okay, once we do so, or once you do so, you will notice that number 3 does not equal 3 when you plug in -4 and +16. So number 3 would be no solution. All right, on number 4, we want the absolute value by itself on one side, so we have to add over this a, and we have a 2a plus another a would be a 3a plus 23 equals the absolute value of a plus 5. Now, just like the other 3 equations, you get 2 new equations. However, you change the sign on your terms. So, we have 3a plus 23 equals a plus 5. And we also have negative 3a minus 23 equals a plus 5. So here, all you do is solve your equations, get all of your a's on one side, get all of your constants on one side. So this would turn out to be 2a equals -18. On the right side, using this negative equation, it turns out to be -4a equals 28. And you divide your terms by your numbers. A equals -7 for this one. And for here, you get a equals -9. Now, if you plug in both of these terms, -9 and -7, to your original equation, you will see that only one of them works. The one that works is a equals -7. Okay, so -9 does not work. These are just solving equations. Just remember that when absolute value, you have both a positive answer and a negative answer. Otherwise, you're just solving like normal, okay? All right, these are inequalities, and we talked about quadratic and squared inequalities a couple weeks ago. So the same rules still apply. So remember, when you have a greater than or less than, you have an open circle. When you have a greater than or equal to or less than or equal to, you have a, bless me, a closed circle. And you can just add that to your paper somewhere. All right, so on this first one, just like before, we are still solving a equation, except it's absolute value. So remember, you're going to have 2 equations. M minus 1 is less than 4, and M minus 1 is greater than 4. -4, sorry. So on inequalities, not only do you make your answer positive and negative, but you also have a greater than and a less than, okay? On the first one, you just solve. So plus 1, M is less than 5. Plus 1, M is greater than -3. All right, here we want to put open circles on our solution. So we do what? That's good. We put an open circle on 5. And we put an open circle on -3. Oh, darn it. I didn't mean to do that. So we had an open circle on 5 and an open circle on 3. And our 2 equations were M is less than 5, and M is greater than -3. Okay, so you want to shade where the point on your arrow is going. So if we look at this first one, we see M is less than 5. We'll look at your point. Everything that's less than is going to be on the inside. If we look at M is greater than -3, it's going to be to the right. So this inequality reaches from -3 to 5. Okay? On number 6, before we start, look at your equation. What are we doing? We are dividing by a negative number. So remember, before you start, you have to flip your sign. You must flip your sign when it shows that you're dividing by a negative number. Okay? So before we start, we have the absolute value of 2y minus 1 over -3. We flip our sign, just like so. And then we solve, just like a simple equation. There's the simplified first equation. The second one, remember, we do two different things. 2y minus 1. Change your sign. Change the sign on the number. All right, once we solve those, we add 1, add 1, we are going to have closed circles because it's less than or equal to, greater than or equal to. So we will have a closed circle at 8 and at -7 once we solve those equations. If you notice, your arrows are pointing outward, so we shade on the outside of both sides. Okay, now on 7 and 8, I want you to do those by yourself. So before you start, you have to get the absolute value by itself. So on 7, you're going to first subtract 11. On 8, you're going to do two things. First, you're going to add 12. Then you will divide by 8. Don't forget to change the sign of your answer. If it's positive or negative, you got to have both. And then also don't forget to flip your sign so you have a greater than, less than, greater than or equal to, less than or equal to. Okay, so it's just like number 5 and number 6. All right, on the next side, discriminant of a quadratic equation. All right, this will help you tremendously when it's asking for solutions. Using the discriminant that tells you how many solutions you have and the types they are. So our discriminant formula is what's under the radical and our square root. So b squared minus 4ac is our discriminant. If the discriminant is greater than 0, meaning it is positive and it is a perfect square, so answers like the square root of 64, the square root of 49, the square root of 25, things like that, it will have two real roots. They will be real numbers and they will be rational, meaning They stop. They do not repeat. They are not a crazy, they're not a crazy decimal. They stop or they just keep repeating like 0.33333. The next one is when the discriminant is also positive, however, it's not a perfect square. It is still 2 roots. It is still real, except this time it will be irrational, meaning it is a crazy decimal. And it just keeps going and going and going. All right, if the discriminant is equal to 0, it has 1 real root. If it is less than 0, meaning it is negative, it will have 2 non-real imaginary roots. So it will have that little I in there that we've learned about. All right, so on this first one, go ahead and let's list A, B, and C. So remember, A goes with your x squared term. So the number in front of x squared is just our 1. The number in front of our x term is our b term, which is 12. And c is our constant, so that will be negative 27. Okay? Now we take those 3 terms and we plug it into the discriminant. Remember, when you plug in, you must use parentheses. So we have 12 squared minus 4 times 1 times negative 27. When we simplify all of that, we get 252. So, since that is greater than 0, we know we will have 2 real roots, but will they be rational or irrational? To find out, you take the square root of 252. When you take the square root of 252, you see that you get 15.87450787. Crazy decimal. So 2 real and irrational. Okay? All right, 19 is the same way. You can do 19 by yourself. Not 19, sorry, 10 by yourself. Let's look at number 11. Number 11, everything has to be on one side. So in order to find the discriminant, the first thing we have to do is move the 1 to the other side. So we have a quadratic equation of 2x squared plus 11 minus 1. Well, we can combine those terms. 2x squared plus 10 equals 0. Okay? A equals 2. B equals, well, B is an x term and it's missing, so it's 0. C equals 10. You take those 3 terms, plug them in to your discriminant, b squared minus 4ac. Solve it. You should get an answer. Tell me what kind of roots it is and how many. For number 12, everything has to be on one side. I'm going to subtract x squared and I'm going to add 12x to both sides. So I've got 4x squared plus 12x plus 5 equals 0. A equals 4, B equals 12, and C equals 5. Plug that in and see what you get for your discriminant. All right, on 13 through 21, These are solving quadratic equations, okay? So, the first one, let's go ahead and do the big X. Before we do the big X, though, what do I have to do with 27? I have to move it over. Everything has to be on one side. It all has to be set equal to 0. So I have x squared minus 9x minus 70 equals 0. Okay? We draw this x. And the bottom of our x is negative 9. And the top of our x is negative 70. Okay? This might be a little tricky. Think of things that multiply to 70 besides 7 and 10. Well, do 70 divided by 2. You get 35. Is 35 and 2 anywhere close to negative 9? No. 70 divides by 5 also. And 5 goes into 70 14 times. So let's do a 14 and a 5. But how can I get negative 9? Which one has to be negative? The 14, okay? So I have as factors of x minus 14 and x plus 5 equals 0. In order to solve these equations, I set both things equal to 0. X minus 14 equals 0. X plus 5 equals 0. Add 14. Subtract 5. Have two solutions. X equals 14 and negative 5. All right. For number 14, I'm going to show you the quadratic formula. You've got to know this. Negative b plus or minus the square root b squared minus 4ac all over 2a. Okay? Using number 14. A equals 1. B equals 8. And before we determine C, what do you have to do with 5? We have to subtract it over. So we have C equals 28. Okay? Now we plug in our values. Negative 8 plus or minus the square root of... Wait, let me back up. B is a negative 8. So we have negative B plus or minus the square root of B squared minus 4 times A times C. All of that is over 2A. So if you notice, I've used parentheses every time there's a letter in my equation when I'm plugging in for a value. Okay? On this first one, these two negatives make a positive. So we have 8 plus or minus the square root of 64 minus 112 all over 2. Now, when we subtract what's under the radical, we're going to get 8 plus or minus the square root of negative 48 over 2. Now, I cannot have a negative square root. But what I can do is take the positive square root and put the I on the outside. So this answer would be 8 plus or minus I square root of 48 over 2. Now you can actually keep going and simplify that radical if you wanted to, but let's leave it at this for easy math. All right, I'm going to show you one more easy way, and then I'm going to let you practice the rest of them on your own. All right, on a question like this, this one is fairly easy. So first, it depends on your numbers. If your numbers add out to be easy numbers, I would go the easy route. So for instance, if we add 7 to both sides, I've got 2x squared equals 120. All right, well, you know in your head that you can divide 120 by 2 and get it whole number. So I'm dividing by 2. So I've got x squared equals 60. Well, to get rid of a square, you take the square root. So I have x equals plus or minus the square root of 60. And then I'm done. If you wanted to simplify the square root of 60, two things that multiply to get 60 are, let's see, 15, 30, 45, or 15 and 4. This goes down to 3 and 5. This goes down to 2 and 2. So, circle your pair. Box what you have left over. Your pair goes on the outside. What's left goes under the inside. And all I did was put my pair here. I got 3 and 5. Multiply, you get 15. So these two are actually the same. All right, on the last 4, I want you to do them on your own. But before you start, just make sure that everything is on one side. These equations have to be set equal to 0, otherwise they do not work. You can use the big X, you can use the quadratic formula, or you can use that simple method that I just showed you where you just add, subtract, divide, square root. Whichever one is fine. All right, so let's get down to number 21. All right, so this is a word problem, so I know you're automatically thinking this is hard. However, it's very simple. It's got a bunch of words that mean a bunch of nothing. Okay, the only thing you need here is how long does it take the ball to reach the ground and this equation? Well, when something hits the ground, what is the height of it? If it's on the ground, the height is obviously 0. So all you're doing is setting this equation equal to 0, and you are solving a quadratic formula using the big X, whatever. I would suggest the quadratic formula on this one because it does have big numbers. And you'll notice, once you get done, we'll have a negative number. So let me work through this one. When we plug into the quadratic, we'll have a negative 40 plus or minus the square root of 40 squared minus 4 times 16 times 5 over 2 times 16. once I simplify all of this, I get t equals negative 0.14 and 2.64. Well, we are talking about time here, so we can only have one solution, and it has to be the one that is positive. This one will not work because it's negative. Okay? Now, remember, when you get to something like this right here in the quadratic formula, you break it into two functions, two formulas, whatever you want to call it. Negative 40 plus and negative 40 minus. Two functions. Quadratics, how many times does it cross the x-axis? 2 times, because it looks like this when you graph it here and here. Okay? All right. Just on that part. Okay. I didn't ever hit record, so what I just did is I marked out 24. On 22, I just factored out an x, solve for the big X. So if you need to, you can pause the video, look at the work, and see what I've done. Okay? Alright, I'm going to move on though, but you can pause it. So I'm going to erase this. On 23, we have a cubic function. They both have a number that 3 and 24 can go into. Okay? Let's try 3. I factor out a 3. I want a 3x cubed, but I only have a 3. So I should multiply by an x cubed plus 8 equals 0. Okay? So, now we have a sum of cubes. Okay? We did sum of cubes on the first video and in class before. Remember, it is a plus b, a squared minus ab plus b squared. So, what we can do here is take the cube root of x cubed, and we get x, and the cube root of 8, and we get 2. We plug those into our equation. Like so. All right, now we've got two equations. Set them both equal to 0. Here, you would do the big X. Let's see, can you do the big X here? You cannot do the big X here because there's not something that works out. So in this case, you would have to use the quadratic formula. Okay, you would have your solutions that way. Let's see. On the last one, 25, we group. So when you group, we draw a line straight down the middle. We're going to factor out an x squared on the left and a 2x plus 1 minus 8, 2x plus 1. The goal here is for my parentheses to be the same, okay? Once they are the same, you know you're on the right track. It's our common factor. We write our common factor one time. X squared minus 8 is what we have left over. Common factor, 2x plus 1 equals 0. All right, we can solve those two equations. So I'll work them over here. X squared minus 8 equals 0. And 2x plus 1 equals 0. The right one's very simple. X equals negative 1/2. The left side is also very simple. Plus or minus the square root of 8. All right, so now, like I did in the first video, excuse me, I want you to do the quiz by yourself. This quiz is fairly easy compared to the first one. But, however, like I did, I am going to give you the answers. But, please know that if you come in tomorrow with just the answers circled and no work to show, then you can best bet you're not going to get the grade you want. So, let's see, there are only 12 on this one. So number 1 is B. Number 2 is B. Number 3 is C. Number 4 is B. Number 5 is C. Number 6 is D. 7A. 8C. 9B. 10A. 11C. And 12B.